Okay, so I've got several topics that I'd like to discuss with you today. Most of these are actually fairly short topics. That's why there's so many of them. We're going to start off with a discussion about interfaces, move on to exceptions, and then at the end, you see we'll talk about hopefully some collections, as well as a couple of other tricks that'll help you when you're working on the problem sets and writing new code. First up, interfaces. So on Thursday last week, I introduced you to this idea of inheritance, right? And what inheritance allowed us to do was specify an is a relationship. So I could say, I believe the example that I used was a cat is an animal. And by saying that, then a cat could reuse some of the functionality, some of the methods, some of the properties from the animal class. Or if it wanted to, the cat could override the methods and implement them in its own way, specific to its own needs, right? So we talked about inheritance last Thursday. Interfaces are a very similar idea to inheritance. But first, let me explain why we need interfaces, what they're actually useful for. There are some relationships that cannot be expressed as an is-a relationship, like inheritance requires. However, there's still behavior in common between two objects that we would like to be able to represent somehow, that we would like to be able to consolidate and consistently refer to those objects. So interfaces can be used to specify behavior that's going to be shared in common with multiple objects when inheritance is not appropriate to do so. Another example when you might want to use interfaces are perhaps there is an inheritance relationship that could possibly exist. There is an is-a relationship, but there really is nothing in common between the two. There's not a whole lot in common. There's not a whole lot to put in your base class, for example. An interface might be appropriate for that reason. And then a final reason when you might want to take a look at interfaces, inheritance, you're limited to one base class. I can only inherit from one object. But with an interface, I can actually have as many of those as I want. And I'll try and show you some examples of all three of those particular situations as we go through today. So the first case I want to look at is this interface right down here. It's called measurable. I always like to express how we define these relationships, right? So we saw has-a with properties within a class. We saw is-a when it comes to inheritance. Something is a something. With interfaces, I like to refer to it as a can-do. So something that uses this interface can get an area, can get a perimeter, right? You'll notice that these definitions down here don't have any implementation to go with them. They're just the signature part, right? I've defined a method. I can tell what its name is. I can tell there's no input parameters. I can tell that its return type is a double. But I don't know how it's actually being computed, right? I don't know what this is actually going to do. And that's actually a feature of interfaces. Interfaces allow us to specify behaviors that we want to be shared across multiple objects, right? But the objects themselves that use the interfaces are responsible for defining the behavior, for implementing the methods of the interface. I like to think of interfaces like a contract. I've created this contract, and in just a minute, I'm going to create some objects that sign up to use this interface. And as part of the contract, they must create these methods and implement them. So let's go ahead and do that. Let me show you how that works. I'm going to create a new class. Oops, that's the wrong folder. I'm going to create a new class over here. First thing I'm going to create is called circle. Right. And so a circle has a radius. I think that's really all that I need, right? Let me create a quick constructor here for my circle and set the radius. So here's a very basic circle class. the next thing that I want to do is actually have it use this interface. And so there's going to be another keyword, implements. You see IntelliJ is helping me out here. So for inheritance, we saw extends. I can extend a class. That's inheritance. For an interface, I implement the interface in question. So here it is. I'll go ahead and implement the measurable interface. You'll notice IntelliJ is mad at me right now. It's telling me there's a problem. If I hover over this, you see it must implement the abstract method. It must implement the methods from the interface. Get perimeter, right? And if I did that one, it would then complain that I haven't implemented get area, right? So IntelliJ can actually help us out here. If I do this, you see there's an option to implement methods. If I click this, it allows me to select which methods I want. I go ahead and click OK, and it'll plug them in for me. And now all I have to do is fill in what I want these methods to do. So for a circle, the area is pi r squared, right? So it's math. Oh gosh, I cannot type. Pi times r times this dot radius. Okay. I want to return that value. And for perimeter, it's oh gosh, 2 pi r, right? 2 times math dot pi times this dot radius. I'm sorry? Oh, at override. So this is just simply indicating that these methods came from somewhere else. I didn't create these methods in this class. I didn't create these methods here. These methods came from somewhere else. Namely, they came from the interface, right? These methods exist to fulfill the contract that I signed when I implemented this interface.
Now, IntelliJ put that in there for you, but if we didn't have IntelliJ put those methods in there, are we having to type that ourselves?
You would have to, they have to be in there one way or another. It's usually more convenient to have IntelliJ do it, right? But yeah, you can type them in manually. In fact, I'm not even sure that you need the overrides here in order to make things happy. I think even that's optional. Although it's not a bad thing to leave them in. And so just to show you, again, I just went ahead and implemented this interface. I went ahead and completed this contract. But just to show you really how interfaces are truly useful, I'm going to create another class called Square. And I'm going to have Square implement that same interface as well. Oops, I cannot spell. There we go. So a square doesn't have a radius. A square has, what is it? I don't know, a length, right? I can create a quick constructor for my square. I cannot type very well today at all. So there's a quick constructor. And now, again, IntelliJ is mad at me because I have to fulfill my end of the bargain with this interface. So I'll just do the same thing. I'll tell it to implement the methods. This time, though, the implementation is going to be different, right? The area is going to be this dot length times this dot length. And the perimeter will just be 4 times the length for a square. And that really, I think, is the main takeaway of an interface. It allows me to specify the same behavior on multiple objects, especially when that behavior is going to be different in each of those objects, right? So it allows me to specify behaviors that are in common. Are there any questions about what we've done so far? I'm not quite done with interfaces yet. Are there any questions about creating interfaces, implementing interfaces? You have to reference, I'm sorry. They're all in the same folder, so I don't need to do anything. I don't need to import them or anything. If they were in different folders, if they were in different modules, then I would probably have to import them. But since they're all in the same place, I don't have to do that. Where I get what? I wrote this. I created this interface right here. No, I created this interface. This is a file that I wrote ahead of time. So this is actually how you define an interface, and that's something I actually wanted to talk about in a little bit more detail, right? An interface defines behaviors, so I can stick whatever method signatures in here that I want. Let's say I come in here and I want to add another one. What's something else that I can do with these? Double number get number of sides, right? Actually, that wouldn't be a double. That'd be like an int, right? This may not be the greatest example in the world, but if I want to add more stuff to my interface, it's just as easy as adding a new method, signature. Notice I didn't implement it, right? Interfaces they don't care about how the methods actually work. That's not their purpose in life. They're just defining a common set of behaviors. And so now that I've added that new method signature here, right? Again, IntelliJ, you see, is mad at me. So again, I am required to fulfill my contract by fixing this. That actually happens to be correct for a circle. Actually, one. I don't know. It depends. I'm not. Correct. Yes, the methods have no functionality until you implement them in the classes. Yes.
So I know we're just talking about a simple example, but if each class has to define its own methods for those things you outlined in the interface, I mean, do you really need an interface other than to just show recommendations?
Yeah. So let me show you then. That's a great question. So, what's the point of all of this if I can just go in and define these methods anyway, right? I'm doing all the work in the classes. Why the heck do I need this interface? Well, let me show you. Do you remember that concept of polymorphism from inheritance? Or let me just go back to, let me just create a main method in here. When we use inheritance, we saw this idea that I can refer to an object either by its actual class, or I can refer to it by its base class as well, right? I could say that a cat is a cat object. I can also say that a cat is an animal object because a cat is an animal, right? That's how inheritance works. Well, I can do the same thing with interfaces. I can say measurable C equals new measurable, oops, not what I wanted, new circle, sorry, and plug in a radius, right? I can also say measurable, gosh, I cannot type that word for any, S equals new square, and give it a length, right? And now, even though I've created two distinctly separate objects, circle and square, I can refer to them as if they are both measurables. I can refer to them by the interface that they implement. And so if I wanted to now, I could create a measurable array, for example. I don't know. Do that right? Yeah. Right? And I can stick both of these objects into this particular array. I did a very similar example to this with the inheritance one, right? C, and then I can set this one to be S. And so now I have an array that references these objects by their interface. I can keep anything that references this interface, anything that implements this interface in the same collection. Not only that, because they implement this interface, because I know that these objects implement this interface, I know for a fact that they have the methods that are defined in the interface. I know for a fact that I can call getArea on these objects. I know for a fact that I can call getPerimeter on these objects because I know that they implement the measurable interface, and part of implementing an interface, part of fulfilling that contract is implementing those methods. If I didn't have the interface, then I'd have to guess. Do they have a getArea method? Do they have a getPerimeter method? Maybe they do, maybe they don't. Maybe the names are slightly different, so I have to call them slightly different on each of the objects, right? So it's allowing me a consistent way of accessing these objects. That's really the importance of these interfaces. Does that make sense? Does that kind of help clear things up a little bit? Why these are so useful? Okay, cool.
So what if you had a class called shapes, and these are subclasses, the circle and the square? So you make
That's a great question. Yeah, so you can, the question is, what if we had a base class called shape? And you're absolutely right. I could use that because a circle is a shape and a square is a shape. So it makes sense, right? From the way that we talked about inheritance, that would make sense. In fact, I think there are situations where you would want to do that very thing.
But now you can't. Can you also have, like the interface with a subclass?
You can, yes. You can implement an interface as well as inherit from a base class. Yes, so if I wanted to, I could say extends shape. I need a comma there. It's mad at me because I don't have a shape class, right? But this is perfectly legal in Java to do. Not only that, so I can only extend one class, right? If I extend shape, then I've used my slot. I can't inherit from anything else. But with an interface, I can go crazy with it, right? I can include as many interfaces out here as I want. Maybe I don't need. I don't remember if I need that comma there or not. I'm going back and forth on it. So there are other interfaces that exist. Like here's one that Java provides called Clonable that I can tack on the end here. There's other ones that Java provides too. Although I'm struggling to think of them off the top of my head. You'll notice this extension, a bull. What is that? An adverb? Is that right? It's a common postfix that you see on naming these interfaces. It's not required. Yeah, it's not always going to be there, but it's pretty common to see this. If you see something that ends in ABLE, it's almost a guarantee that it's going to be an interface if the programmer is following convention. Any other questions? Anything? Let me check my notes and make sure that I covered everything that I wanted to. Yeah, I think I did. One other final note about interfaces before we move on. You'll notice I only declare methods here. You can actually include properties as well. I actually don't like this too much within interfaces because these properties have to be public. They have to be. I can't declare private properties inside of an interface, and I'm just not a fan of public properties in general. So you can do this. You may see it. I try to avoid this. And so actually, I think they also have to be constant as well. Yeah, they do. It wanted me to set this to a value. So it has to be public and constant. I do not use interfaces for this nearly as much, if at all. I use interfaces mostly to define behaviors, not properties.
The methods we have here are almost as if you're guaranteed that there's going to be an instance variable method. Right?
Sure, yeah. I mean, the way that these methods, so the question is, are we kind of guaranteeing that there's going to be instance variables? I mean, you're sort of guaranteed there's going to be instance variables in any class ever, right? What's a class if it doesn't have any? But even still, the instance variable here is not called area, as the name implies. The instance variable for circle was called radius, and for square it was called length.
Okay, yeah.
So that's really, again, it hides the implementation details. It lets the classes handle their own implementation and just defines a consistent set of behaviors. You can't. You actually cannot. If I tried to, it would not let me do so. It will get mad. Yeah. You cannot define behavior in this interface. You should also be careful when you're creating interfaces too, right? Make sure the behaviors are actually related in some way. Don't just start slapping method signatures into an interface because you use them together. They should be related. All of these apply to something that can be measured, right? So you could envision this applying to all different kinds of things, not necessarily even shapes, right? I could create like a property class, you know, like a piece of land, and apply this interface as well, right? And it would make sense. It would apply. Okay. Any other questions about interfaces? You'll get some practice writing an interface and implementing it in the next problem set. If there aren't any questions about that, I want to move on to my next topic, which is exceptions. You've probably already seen exceptions before. In fact, I'm like 99.9% certain that you have seen exceptions in action. You just may not have realized it or realized what it was talking about. If you see an exception, it means something has gone wrong. Exceptions are an indication that something bad has happened. So if there's ever an error in your program, it throws an exception. That's the terminology. We say it throws an exception, which means that it basically raises a flag to say, hey, I have some kind of a problem over here. And then once that exception is thrown, once that exception is raised, there's basically two options. You can do something about it. You can handle that exception, or you can just let that flag wave in the air, which eventually is going to crash your entire program. It'll bring the whole thing to a screeching halt, right? So let me first show you how we can actually handle exceptions. And I'm going to do this with a file example too. I'll show you how to read in files as well while I do this. So let me call this exception practice. I actually don't really need this to be a class per se. I just need this to be like a main method. So let me just stick a main in here. Oops. So let me show you how to read in stuff from a file first, and then I'll show you how to handle use exceptions at the same time. So to read in stuff from a file, we can use the scanner class, which I know that some of you have already used. The only thing that we have to make sure that we do is we create a file object. And so when I create a new file object, I have to tell it what I want, right? Text file or whatever. So it's mad at me, cannot resolve symbol file. This means I probably need to import it. Let's see if I can get IntelliJ to help me out with this. It's easier said than done. Come on, IntelliJ, hook me up. Where's that light bulb? That's what I want. It's not doing it for me. Well, oh, shoot. There it is. All right. Import class. That's the one I want. I probably could have typed it out myself faster than that, but it's over now. So then I'll create a scanner. And instead of passing system.in here, I'll pass the file instead. And again, I need to import scanner. Let's see. I'm just going to type it out this time, maybe, since it's going to, yeah. Java, what is it? .io scanner? Nope. Java.util.scanner. There it is. Okay. And so you'll see, actually, that even though I've done this correctly, I promise you that I have. I've created a file that I want to read in, and I've created a scanner object that I want to read from that file. You see it's mad at me. It says unhandled exception. What it's telling me right now is that this file may not exist. In fact, it doesn't. This file does not exist. I have not created it. If this file doesn't exist, then I have a problem, right? If this file doesn't exist and I try to read something from it, that's a problem. I can't do that. That could potentially crash my program. And so if that happens, if that file truly does not exist, it's going to throw an exception. It's going to raise a flag. You see the exception it's going to throw is called file not found exception. It's appropriately named, right? I need to handle this exception. It wants me to do something about this possibility. It's not telling me that whether or not the file exists or not. That's not what it's telling me. It's saying there's a chance that the file doesn't exist, and I want you to be prepared for that case, should it happen. So the way that we handle this is with what we call a try-catch block. I'm going to wrap this code in a try block. And then after the try block, I'll say catch the file not found exception. I do need parentheses here, I believe, around that stuff. Oh, variable f is already used. Okay. E. There we go. And so what is this actually doing? It's going to try to do the stuff that's inside of this block. It's going to try it with the realization that it may work or it may not. If it works, if the file exists and everybody's happy, then it's just going to skip over this catch block and move on to whatever's down here, right? It'll just move on. It'll continue forward. If there's a problem, if the file does not exist and this exception gets thrown, this exception gets waived, then it will do whatever is inside of this catch block. So I can say system.out.println, this file doesn't exist. Now, typically, you may want to be a little bit more detailed than this. You may want to, a nice thing to do would be to, especially if I'm asking the user for information, would be to reprompt the user in this case, right? Sorry, the file that you specified doesn't exist. Please type in another file name, right? That would be perhaps a better way of handling this particular behavior, but this is I'm trying to keep this example simple. So if I run this file does not exist, right? It's empty, or it's not empty. It just doesn't exist. So I would expect to see this message actually get printed out to the console. Oops, I ran the wrong thing, which of course I did. Let me stop this. Oh, it's mad at me because of my interface stuff. Wonderful. That's not even what I want you to run. Yeah, it's mad because of the interface stuff. Let me just. If they're inside of the same source, then it's going to try and check all of those files, whether you're actually using them or not. So what you can do is create a new module and just copy that stuff out into a different module. Keep it separate so that you don't run into that problem. Yeah. Okay, one more time. It's gonna work this time, and by work I mean it's gonna fail and throw an exception. There it is, right? There's my message. If I create this file, which I think I should be able to do. No, I will not add that to Git. If I create that file, now this file actually exists, right? Then I can add another system.out down here just to show you that it does in fact work. Again, what I wanted it to do is find the file. Why didn't it find the file? Maybe I need to put that in here in the source folder. One more time. There. Well, shoot. Apparently, it can never find the file. Why is that? Where does it want me to put it? Where does it want me to put it? I don't even know what else I would try. Like that, you mean? Oh, source slash. Well, yeah, I'm not sure what the issue is. I'll have to look into that. Yeah, it's telling me it doesn't exist when clearly it does. Here, I'll just do it this way. That's a little excessive perhaps, but it'll work. Found the file that time. You see what I did? I just right-clicked it and said copy path, and then just pasted it in. There should be an easier way to do that, but I don't want to spend more time on it. This is sufficient. You see that once the file actually exists, right? This exception doesn't get thrown anymore, so this code does not execute. So this code here is only if something bad has happened. I want to print out an error message. I want to prompt the user to try again. I want the user to do something, right? Or just give notification. At the very least, you should give some notification of what happened. You should, yeah, you should close the file, actually. Thank you for bringing that up. Do scanner stuff. And then say f.close. Nope, there is no f.close. I guess you don't have to close the file. In C, you definitely did, right? No. Again, Java is managed. Java does garbage collection and all that fun stuff. So it's taking care of that for you. But anyhow, this is how we can catch exceptions. This is how we can do things if we suspect that something bad might happen. You'll notice in this case, I didn't have a choice. I had to. I had to use a try catch here. It was mad at me when I did this because of this file. The reason for that is there are two different types of exceptions. There are checked exceptions and there are unchecked exceptions. Checked exceptions are like the ones that I just showed you. Checked exceptions usually occur when there's some kind of problem with user input or input in general. So things like file names, things like prompting the user to type something in on the keyboard, stuff of that nature, stuff that's external to the program that can go wrong. Usually we'll throw a checked exception. You have to handle those. You have to catch them. Or the alternative to catching them is to throw them, which is to basically say, not my problem, and pass it up to whoever else is available to handle it. The other type of exceptions are unchecked exceptions, which are probably the kind that you've seen. You might have seen a null pointer exception. You might have seen an array index out of bounds exception. You might have seen, oh gosh, I don't know, other kinds of exceptions. Invalid argument exception you might have seen. Those are some of the more common ones. Those typically are not caught. They usually indicate a bug in the program. We don't want to handle those. We actually enjoy those exceptions because they tell us that we did something wrong on the programming side, that we made a mistake. It's not our users. We can't blame our users for everything, right? We can only blame them for most things. So unchecked exceptions like that are our fault. They're our responsibility to deal with. We can actually throw those exceptions of our own. So if I come back to, like my circle class and I see this radius value cannot be negative, right? I can't have a circle with a negative radius. It doesn't make any sense. So if I wanted to indicate this in my code, if I wanted to do a little bit of data validation, you guys did some data validation in CS52, right? We could do that here using exceptions. I can say if the radius is less than or equal to 0, 0 might actually be OK. Let's just say strictly less than. Then I can throw a new illegal argument exception, which indicates that I gave a bad value, right? I gave a bad value to this constructor. Yes, question? Well, the normal errors, bugs that you've been seeing are actually typically going to be exceptions in action. I mean, that's what you're seeing. The other kinds of bugs that we haven't talked about, although I'm sure Chris has talked to you about them before, are logic bugs, where things work, you just get the wrong answer. Like it doesn't crash, but you get a value that's not the value you wanted. That's not what exceptions are for. Exceptions are for if I want the program to stop. You should throw an exception if there's no way for you to proceed with the information that you have. If you cannot continue, then you throw an exception to tell the program to just stop, right? Yes.
This is an unchecked exception.
Yes, it is an unchecked exception, correct.
What does that mean possibly?
So an unchecked exception is not required to have a try-catch statement.
How would, okay, so what if you wanted to check? What do you type? What do you do differently to make it?
So it's actually just from looking at the exception, you cannot necessarily tell whether it's checked or unchecked. You have to check the documentation for the exception to determine whether it's checked or unchecked. The best way to know, though, I mean, for the most part, you can move along as if exceptions are not there. If you come across a checked exception that requires a try-catch, IntelliJ will tell you. IntelliJ will tell you there's a possible exception here. It will even write the try-catch code for you and insert it into your program for you. So
it's just certain exceptions
certain
are checked and others are unchecked.
Correct. Checked exceptions usually deal with stuff that is outside the control of the program. File input, user input, stuff like that.
And so if you throw that inside your circle thing, and then someone else or you somewhere else tries to use it,
Yeah, so
then you might get a compiler.
if I come down here and I stick -5 in here, right? And I ran the wrong file. That's, of course I did. And then I try to run this file again with the inappropriate value. It will now throw that exception.
Right.
Illegal argument exception, right?
And if you had a different exception in there, having to checks type, then you wouldn't be able to compile this right now, right? Because the compiler is that you need to surround your thing.
Well, so throwing and handling are two different things. When I throw an exception, I'm basically saying that whoever calls this method, whoever tries to create this object, has the option whether to deal with it or not. If they deal with it, fine. If they don't deal with it, you're going to see what you see down here, which is the program comes to a screeching halt, right? So at this point, you know, when I throw an exception, it's out of my hands. Like I'm basically saying, okay, not my problem anymore. Whoever uses this method, which in all fairness could be me, right, later on in the program, then has to decide whether they want to handle that exception or not.
When do we have to declare that we're throwing?
Oh, you mean on a method? Yeah. So if we
Is there a difference between a constructor and just a general method in terms of declaring that we're throwing?
I don't believe that there is. No, I haven't actually gotten to. You're talking about like up here, right? Throws. Yeah. So the other option that you can do if I have a checked exception like this one. Let me copy some of this code into a different file. I don't want to do this in main. Oh, come on. And where do I want to put this? I really don't want to do it in main. I'll do it down here, I suppose. Yes. So the other thing that I can do with exceptions is, again, it's mad at me because I need to, of course, I need to import scanner again. Ugh, I should have just kept it in that file. So it's going to get mad at me because I have this checked exception. I have to do something about this. The way that I handled it before was I used try catch, which means I'm going to take care of it. Try catch is basically saying I'm going to handle this myself. If I don't want to handle it, I can pass the buck. I can say, all right, I recognize this exception is here, but I don't want to deal with it. So the other thing that I can do is I can say, well, this method potentially throws file not found exception, right? Get number sends. Oh, because it's in the interface, yeah. Well, I totally blew this example. I can say what I was trying to get is I can say that this method throws this exception, which means then whoever calls this method now has to handle it. It's not my problem, right? I'm basically saying, get this out of here. You know, I recognize this could happen, but I'm not going to do anything about it. Whoever calls this method has to do something about it. So I pass the buck on to them, and then they have the same choice. They can either use try catch, or they can throw it. But if it keeps getting thrown, keeps getting thrown, keeps getting thrown, eventually it'll reach main, right? Eventually it will reach the top, and if nobody handles it, then it's going to crash your program. Which for a checked exception is just unacceptable. For an unchecked exception, it's actually okay. For a checked exception, it needs to be caught somewhere in your program. It has to be. So I'm actually not a huge fan of this. There are cases where it's appropriate. If I can catch it, I will. If I have a reasonable way of handling it, I will. I personally, I rarely do this, but you can. It is an option. What else did I have about exceptions? You can create your own exceptions, but I think I might actually put that off until a future lecture. I think we've covered enough for now about exceptions. I want you to get some practice doing the basics first, some try catches and some throws first, and then we'll talk about making your own exceptions. Any other questions about exceptions that I can answer right now? Okay, let me take this off, actually, and undo this so that it's not mad at me anymore. I just had a couple other things. We got 15 minutes. Great. I just had a few other topics I wanted to talk to you about. We've been using a lot of arrays, right? And arrays are wonderful. I don't want to talk bad about arrays, but I'm kind of going to talk bad about arrays because they do have some problems. The biggest problem, the most frustrating thing about arrays is once I declare how large they are, that's it, right? I can't change it after that. That's real annoying. You saw a structure in CS50 that didn't have this restriction. Do you remember what that was? A list, a linked list. I can add as much stuff to a list as I want and happily accepts it. Java has some of those constructs as well that are available for you to use. So I want to show you a couple of those to kind of wrap up today. You can create one final class. Called collections practice. And again, I think I'll just stick a main in here so we can play around with stuff. The nice thing about Java is just the Java library is pretty robust. It's got a lot of stuff included in it. One of the nicest things that you'll see people use in Java is what's called an array list. So it's kind of a hybrid between an array and a list. It gives you the nice features from an array and also the nice features from a list. It's an object, so I have to treat it as if it were an object. But it's also kind of like an array. So like an array, I have to tell it what type of stuff I want it to contain. So for example, I can create an array list of strings. Notice here I'm using angle brackets. I'm not using square brackets anymore for these. And I probably need to import this. There we go. You'll notice that when I create this, right, I create it just like I create any other object. This looks a little weird. Array list, angle bracket string, parentheses. Why are these parentheses here? That looks a little funky, doesn't it? It's a method, specifically what method? It's a constructor. I'm calling a constructor for an array list. The reason it looks weird is I have to specify what type, right? So I'm creating an array list of strings. If I wanted to, I could create an array list of students, or an array list of courses, or an array list of circles, or an array list of measurable objects, right? Referring back to the interface. So once I have my array list, the way that I use it is you know, I have to use the appropriate methods. So I can add things, right? Hello. Or I can, you can see all the stuff that's here. If I clear it, that'll take everything out. I can get stuff. So if I get something at a certain index, right? So go to position 0, tell me what string is at that position, etc. So I'm not going to go over all of these. What I would like for you to do is actually take a look at the documentation online for this and get used to looking up the Java API when you need to figure out how to use new objects like this. I just want to introduce these concepts, right? Give you a kind of a push in the right direction. Here's size. That's good one to know, right? So I could even iterate over this, right? Using list.size in my for loop or my while loop to iterate over this list and examine what it contains. The nice thing about an array list, you'll notice I didn't declare a size anywhere, right? I didn't tell it had to be a certain length. If I add new stuff, it just extends it out by 1, just like a linked list does, right? So now having those fixed size arrays are a thing of the past. Don't need it anymore. There was another collection you used for this as well. Use a linked list in conjunction with another type of collection. I heard somebody say it earlier. A hash table or a hash map, right? Hash maps exist in Java as well. The hash map need to do its job. What does a hash map contain?
Hash function.
So there's a hash function, right?
It's more like a PHP associated.
Oh, okay.
Hash table is like that's stuff.
Yeah, I suppose hash table and hash map aren't quite the same thing. You're right. So, well, let me explain what a map is then. A map is also referred to like a dictionary sometimes. You think about, what do I do with the dictionary? I look up a word and it tells me the definition. Or you might also think of it like a phone book. I look up somebody's name and it tells me their phone number. So there's two parts to a hash map. There's keys and there's values. The keys are what I'm using to store things and look them up. The values are just the values that are associated with a particular key. Another way of thinking about hash maps is they're kind of like an array. I can stash stuff at certain positions, but I'm not using integers anymore for my indexes. I'm using basically whatever I want. I'm using strings. I'm using anything, right? So forget the numeric indexes. I can use whatever I want to reference a hash map. But like I did with an array list, I have to tell it what types I want to use. So, you know, just sticking with a simple example, notice I had to specify 2 types, one for the key and one for the value, right? They don't have to be the same. I could do this. This is perfectly OK. In fact, let's do that. Probably need to import it like I did with the, oh no, it did. OK, cool. Import it for me. Why is it mad about int? Does it want integer? Oh, it wants, sorry. So now to use this hash map, I just need to start specifying key value pairs. When I put things into my map, I'll say map.put, but I have to provide it 2 values now. So here's me, right? Jesse. Jesse's a -4. Did I spell that right?
Yeah.
Oh, good. Right. So I'm specifying these key value pairs. Chris, it'll be you. I don't know. What do these numbers even mean? I don't know. Subconsciously, they probably mean something. So I've put a bunch of stuff in my map, right? So now my map contains 3 items, right? If I want to get stuff back out, then I say map.get. And then I plug one of those items back in. So if I plug me in, right? Let's print this out. Oops. There we go. I would expect this to give me the value of 30. Let's try it and see. There it is. Yep. Yeah, so if you want to loop through a hash map, I believe there actually is. Let's take a look here and see. Here it is right here. Although I'm not sure that I would use that. Actually, well, the way that I'm used to doing this, you're welcome to experiment with this if you want. The way I'm used to doing this is to grab this key set. I can grab a set of keys, and then I can iterate through that and plug each key in one at a time. Notice this is a collection. I know it's a collection because it's got angle brackets on it. Whenever you see those angle brackets, that should be a flag in your mind to say, hey, this is a collection. This is a typed collection. So if I wanted to, I could, grab this key set, which in this case is going to be a set of strings. Whoops, why are you mad? Oh, I need to import that too, probably. Well, let's do that. And now I can, if you want to do a for each loop, you actually probably could too. Key in S. And this should then print out all of the keys for me for my hash map. Or if I wanted to, I could say something like map.get. And that would get me all the values out of my hash map, right? Let me run this and just show you that it hopefully does what I expect. There's the keys, right? All 3 of the keys that I put in. Notice they're in a different order. And that's the thing about hash maps is they make no guarantees about order. So just because I put something in there in a certain order does not mean they're going to necessarily come back out in that same order. There are no guarantees for hash maps. You also can't reuse keys. Like if I issue another statement down here, and I say map.put, and I reuse one of my keys, I can only have one value associated with a particular key. So this 30 is now gone. This 30 will be blown away, right? I've set it to be something else. So each key can only exist once inside of a hash map. So I believe I've asked you to use hash maps on the next problem set, which I'll talk to you about in just a few minutes. If you wanted to get some practice with array lists, which I think would also be really good, you could go back and actually replace some of the arrays that you have in your previous problem sets using array lists. That would be a good thing to do. It probably wouldn't take you very long either.
Is that map.put, would that be the preferred method to change the value of the key? Or
yes, actually. Yes. If I want to change the value associated with the key, I just put a new value in for that particular key. Yep. That's the preferred way to do it. And this is really just scratching the surface. Like I said, I kind of just wanted to introduce these concepts and sort of give you a push with them. What I'm hoping that you'll do on the next problem set is look the documentation up for these and kind of find the appropriate methods that you need and use them to help you solve the problem set at hand. Although these,
Salary?
I'm sorry?
Is that my new salary?
Yeah, it's coming from Jesse's salary. It's in pesos. Yeah. Any questions? Since we have just a few minutes left, I've got another. I know I've been jumping all over the place today. I had a lot of stuff that I had been thinking about that I wanted to talk to you about today. I've just got a couple of other really quick topics to cover with you before we wrap this up. The first one is naming conventions in Java. I should have probably talked to you about this last week, like in the very first lecture. Java does things a little bit different from C. I've actually been using pretty good naming conventions, although I'm not perfect either. You'll notice that the name of a class always starts with a capital letter. You'll notice the name of a method always starts with a lowercase letter and then capitalizes the next letter. if necessary, or the next word if necessary. It's called camel case. Actually, camel case is with the, I always get them mixed up. The name of it doesn't really matter. The convention is what's important, right? So methods start with lowercase. Classes start with uppercase. Properties also start with lowercase, right? But how do I distinguish a property from a method then, if they both start with lowercase? There's two correct answers here that I can think of. Parentheses is one, right? If I see parentheses, I know it's a method. Getting a little bit more abstract, though, methods are always going to be verbs. Properties are always going to be nouns, right? So that's another way you can distinguish between the two. Java doesn't enforce that, of course, but that's how it should be. That's how good design should be. Using special characters, using underscores, using anything besides characters, essentially, is usually frowned upon in Java. So I've been trying to point that out when I notice it. I know C, actually, that's perfectly acceptable, right? You did that in C all the time, and that's perfectly fine for C. In Java, however, it's considered bad form. Which I know is annoying, right? You learned how to do it in C, and you're used to typing in all that stuff. And now you have to unlearn it or force yourself to not do it. But such is life, you know. I'm sorry? You can use integers. Yeah, I try to use them sparingly. But yeah, you can use integers in names of things. Typically more variable names, not like I probably wouldn't. I can't think of a case where I put an integer like in a class name or even a method name. Local variables, potentially, I'd be okay with that. Very rarely in a class name, though, or an interface name. I'm trying to think if there's any other naming conventions. Of course, you should try and make your variables as descriptive as possible. That goes without saying. You should have learned that from C as well. As you can see, I'm really great at that, right? I'm doing a wonderful job of descriptive variables. Well, sometimes I do. Sometimes I do well. And then I know I've mentioned this to a couple of other people as well. There's a nice little thing you can use called JavaDoc, where if I do /**, it looks like a block comment, right? It's actually very similar to a block comment. But the nice thing about JavaDoc is, you know, I can add this for each method in my class with a little description about what each method does. Now, these methods are probably self-explanatory. I wouldn't be too picky if you left these off, right? But they're the methods that I have to work with right now. The nice thing about JavaDoc is there's actually, let's see if I can find it in IntelliJ. I had it earlier. Where did it go? The nice thing about JavaDoc is that there's a way to transform JavaDoc into a web page, which makes it very easy to post documentation about your classes online or send them to people. How do I forget how to do that. How do I do that in IntelliJ? I thought I saw it in here. I think I linked to it on the problem set, actually. But this is another good habit to get into once you're done with the project. Go back and stick these JavaDoc comments in. And I'll try and find that documentation on how to do it in IntelliJ. I know how to do it in other programs. I just don't know how to do it in IntelliJ, unfortunately. To post this up online. And then there was one more thing. Oh, yes. The last thing that I'll show you real quick is how to use the debugger. I know I've already showed this to a few people, but it's good to get it down on video. Good to get it set in stone. There's a debugger built right into IntelliJ. It's very hard to see because the way that I usually access it is through this little strip right here on the side of the text editor. So the best way to use it is to go to a line that you're curious about. For example, this line right here, right? And then just click over on the side. You should see a little circle pop up. You've set a breakpoint. that is now a breakpoint, just like in GDB. So when I execute this, the program will now stop at this point. You can't run it with the green triangle. You have to run it with the little bug instead in order to make it work. So let me select to debug this. It'll stop at this breakpoint. And then down here, you can see all of the values that I have available to me at this point, which right now are none because I haven't done anything yet. But I can step through my code one step at a time using these buttons here. This is just like GDB, right? I can step. And so that last line created a file. Here it is. Here's that file that was created. And I can expand it and see all of the properties that it has, everything else that's associated with it. So I can continue to step through, right? And that's actually the end of my program, so I'm done now, right? These examples are pretty simple. You know, debugging these examples is not the greatest exercise in the world, but when you're working on your P sets, when you're working on your problem sets, remember, all you have to do is, if there's a line that's giving you trouble or a line that you don't quite understand what's going on, just click over on this little bar and set the breakpoint. And then it will stop at that point when you debug your code. You can step through and examine your variables, just like you would in GDB. Even easier than using GDB, honestly. Cool. All right, I covered a lot of stuff. What questions can I answer? What questions do you have? Anything for me right now? Or are you guys filled to capacity with all of the knowledge that I dropped on you? Okay, great. Well, that about does it then. The next problem set has been posted. You're actually going to be revisiting something you did for CS50. You're going to be working on the Caesar cipher and Vignere cipher in Java. Great. You liked that one, huh? Or was that? Yeah? Okay. I can't tell if you're sarcastic or not, but